I'd like to start off just thanking the organizers for the invitation to speak to you this morning, and it's a pleasure to be here from Minnesota, finally de-icing and coming out of, we had 20 inches of snow about 12 days ago, and it all melted at once, so all the rivers are full, so exciting times in Minnesota. I've been with 3M 25 years, and I'm going to tell you about what we do, which is try and provide adhesive solutions for people who are making wearable medical devices. And so as those become more and more important, the role of the adhesive in helping that function and making sure the device, particularly in a life-saving mode, does not fall off at an inopportune time. So I'll tell you a little bit about that. Before I get too far into that, I'll tell you a little bit about 3M as well. We're a big company. Many of you probably know about us, Post-it notes and Scotch tape and things like that, Command adhesives and things. So a lot of adhesive knowledge in our company. But there's a lot of things you probably don't know. About 80% of our products don't get sold in the consumer space. They get sold directly to our customers in the graphics and safety and healthcare space. And so we have sales in about 200 countries, very much a global company, sales of close to $32 billion, 90,000 employees globally. And we spend a lot on R&D, resulting in about 113,000 patents over our 115-year lifespan. So, and we're in the Dow 30. So when we announced the other day, we hurt the Dow, and hopefully we'll recover quickly due to the outlook on the year. Our tagline is Science Applied to Life, and I'll tell you a little bit about how we do that, but I also want to mention a new initiative we have around science. I think most of us here are scientists, in some regard, engineers. We care about technology and the impact it has on lives. And science is going through an interesting period right now, let's just say that, in terms of the believability of science, the credibility of science, the importance of STEM in education. And 3M's taking a new initiative around the state of science. And so we have about, of our 90,000 employees, there are 20 corporate scientists. We've assigned one of those corporate scientists to be an ambassador related to science. Her name is Jayshree Seth, and she'll be our ambassador for science and science-related topics. If you're interested in that topic at all, please contact me later, and she'll be going around the world and giving presentations and trying to do things to advance the state of science for not just 3M, but for the world, we hope. I think we all know we're facing some challenging demographics related to the growth in the population, which brings about certain problems. So again, science is going to be, we think, a critical part of solving some of those issues around energy, resources, the population demographics that we have, the digital revolution that we're all experiencing, and the economic landscape that's undergoing radical change. And so we believe science offers a lot of the solutions to that, and we'll be working with partners to try and bring about increased science knowledge and increased science credibility around the world. So just wanted to let you know we're working on that. It's pretty exciting, and that's just rolling out now. Coming back to the Science Applied to Life and how it actually works, our tagline of 3M Innovation. Awesome. Thank you. Our tagline of 3M Innovation, I'll tell you a little bit about how we innovate and how that relates to the science of skin that we'll be talking about here in just a minute. Not advancing. There we go. Thank you. So a lot of innovation is tied to the people, the culture, the creativity of those people, working closely with customers to get insights into what the solutions that are needed in the market and in the technology required. What we view, one of our keys to technology innovation, we have 46 technology platforms that we kind of treat like a periodic table. If you grew up in chemistry or had the pleasure of taking chemistry in school, that periodic table of elements we combine together to make the magic of all these things that we have around us. We do the same thing with our technology platforms. And I call it kind of letting the inmates run the asylum. Those technologies aren't owned by the product divisions that use those. They're owned by the corporation. So any of the scientists involved can take those, combine them in unique ways to create new and breakthrough products. And so related to adhesives, since that's what I'll be talking to you about today, we use adhesives across all of our markets, electronics and energy, industrial, particularly in healthcare, safety and graphics, and consumer. It's the combinations, though, when you combine adhesives with other sorts of technologies that allow you to do some pretty unusual things as well. We sell a variety of high-performance window films that reduce energy load on buildings, as you might expect, rejecting the infrared radiation so you don't have to use as much air conditioning. Unique, most of us grew up with metal in our mouths and things like that. Modern dental technology, you'll hardly ever see metal used in the United States in particular because of some of the breakthroughs that have made around combining adhesives with other sorts of inorganic materials to make materials that look and are in some cases stronger than actual dental tooth material. And then the medical space, which is where I work, we combine adhesives with a variety of technologies to make unique medical dressings that are used throughout the world. So let me talk about the science of skin. So as we talk about the importance of wearable medical devices, skin is one of the most challenging substrates to stick to, and I'll explain that to you. So I'll go into a bit of a deep dive on skin and then how we're trying to overcome those challenges. So why are we thinking about skin? We've heard it throughout the day yesterday. We'll hear about it more today. The chronic disease epidemic, if we can say that, the number of people experiencing problems with chronic diseases, diabetes, sleep apnea, chronic pain, the numbers are tremendously worrying. And in many cases, having access to a wearable device may be part of the critical aspect of the healthcare of that person, particularly if it's heart or other related activities. In the market, our customers that we're working with have been asking for increased wear time, particularly if you're involving a cannula or something that sticks into the skin. People want to change those out less frequently, so they want the devices to last longer. The devices are also getting more complex. If you go out in the parking lot here, look at a car that was built in the early 1990s. On the windshield, there'll be one little piece of adhesive with the rear view mirror. I used to work in automotive, so I know that space. If you go out there and look now at any car built after 2010, you'll see some big giant 6-inch by 6-inch platform where you have a camera that measures the high beams of someone coming at you, water for the automatic windshield. It's a whole platform. And so people are thinking about that in terms of wearables too. It may not just be enough to do an EKG. They may want to know pulse ox and 3 other parameters as well. So those devices are getting more complicated, which means that adhesive interface is critical to the function, particularly if you need conductivity. So extended wear. Easier said than done. Someone asked me yesterday, why not just use super glue? There's a good reason not to just use super glue, because you'll take off 4 layers of skin when you remove it. So it'll be great while the device is on, but the removal process is going to cause unintended consequences. So we have to work a lot on designing the adhesive for the specific application. If it's 3 days, 7 days, 14 days, that we do no harm as well. So I'll talk a bit about injuries that can occur and how to avoid those. Involve a company like 3M or someone who works with adhesives early in your process so that you can get the best solution, particularly if you're going into clinical trials to get the best result. And as you'll hear about, we've been making adhesives for 115 years. We have lots of lab studies that can tell you all kinds of amazing things about adhesives. They don't translate onto skin very well, so we do our own clinical trials, and I'll show you the results of some of those. Future challenges, we heard a lot about the kind of the behavioral science aspects of this. There's stigmas associated with medical devices as well, so we're particularly interested in trying to understand how what we do with the appearance, color, other sorts of things can reduce the stigma associated with wearing a medical device as well. So that's kind of a future challenge that we're looking at. So what do we think about when we think about skin? Most of us don't think about it very much unless we're getting older and wrinkles and things like that, or we spend out too much time in the sun. It's an organ. It's the body's largest organ. We have about 2 square meters of skin. We have about 8 pounds of skin. It sounds amazing. It's our interface to the world. It's a critical part of the function of temperature, calcium, phosphate levels, it's our nerve endings, blood, temperature management. All these things are tied to the skin. So whatever we do to it shouldn't somehow degrade any of those functions of the skin. So it's incredibly important. And again, we take it mostly for granted most of the time. But I'll tell you why it's a challenging substrate to stick to as well. The skin structure, if you haven't studied this, you've got about a 30-micron layer of dead skin on the top layer of your skin. We call that the stratum corneum. That layer falls off, kind of like a snake, every 14 days or so. So underneath it is the epidermis, which is sort of the renewal layer. So new cells divide and grow into, and as they move away from the blood supply, they die and become that new layer of brick and mortar on top of your skin. Underneath that is the regular dermis layer, which is hair follicles, sweat glands, oil glands, all these other things that provide valuable functions of the skin. Again, our interface is that top dead layer of skin, but we also have to make sure we don't do anything to damage the function of the skin because it is a living, breathing part of our body. The microbiology of the skin, we heard a lot about microbiology yesterday in terms of potential for infections. Many people don't know this. For every sort of what we call our skin, our body cells, we have about 10 microorganisms living on us. So you have to think about that a lot to get that through your brain. But a lot of people do antiseptic treatments or antibiotic treatments on the skin. You'll kill that surface layer. Underneath in the hair follicle is a lot of bacteria in the form of biofilms. You'll within 18 hours regenerate all that bacteria. So whatever we do in terms of treating that skin, the bacteria will come back. And you'll notice for longer wear adhesives, you get an odd smell due to the bloom that occurs. And so that could be something we need to look at as well in terms of managing that microbiology. Moisture is also incredibly important. I'll talk about some of the injuries that can result if you don't manage the moisture properly. At the top layer of skin, you have about 15% moisture. Underneath, down in the deeper layers of skin, you have about 70% moisture. That's a critical function of skin, is to make sure we keep moisture in and manage that moisture as part of our temperature control system and sweat. The factors that affect skin adhesion over time, you've got a breathing surface. You've got that cell renewal cycle where that top layer of skin falls off after 14 days typically. You've got an elastic system that regenerates or sort of rebounds up to 50%. You've got a low surface energy. So even though skin has hair and all sorts of different skin roughness areas, it behaves a lot like a low surface energy plastic in terms of trying to stick to it, which is a challenge. You've got hair and other factors, and people use a lot of skin ointments and oils and things like that. So again, that can impact the overall performance of an adhesive depending on how that skin is treated. So we make medical adhesive tapes. They've been in hospitals for about 60 years. There's a lot that goes into that, and I won't spend too much time on this slide. Just to be said that in order to be used in these types of applications, you need to follow good medical practice and follow the ISO requirements associated with that. And also, biocompatibility is a critical part to make sure that we don't do anything that offers any allergic reactions associated with that. Many of you probably remember back to the 70s, 80s, latex gloves, a lot of latex adhesives. Natural rubber can cause severe allergic reactions in people, and so that's kind of off the table now as a medical product. In the 90s or in the 60s, acrylate adhesives, which is the basis of most of adhesives that are out there, and then silicone has come along in the most recent time. That's particularly important with the aged or very young in terms of avoiding skin damage. It's a very gentle to skin material. How do skin injuries occur? Again, going back to the superglue question. When you're taking off a piece of tape, if the adhesion of the skin layer underneath your first layer of skin is weak and the adhesive is strongly bound to your top layer of skin, you'll actually strip off the skin. So that's one of the most common injuries that can occur and should be avoided by, again, the proper selection of an adhesive. I won't go too much into this other than just to say one of the unique aspects of the silicones is when you take a silicone adhesive off and do a quick protein assay, you'll see almost no skin on that silicone. It's a very interesting molecule in terms of how it adheres to skin and the reason why so few injuries result from using silicone. If you use a traditional acrylate adhesive, when you peel off that tape, you'll see a pretty significant amount of protein. So you've taken off, usually not enough to cause an injury, but you take off that first dead layer of skin when you use those adhesives. Something to keep in mind, particularly when working with the very ill, very young, or very old. An ugly picture. Series of pictures, but these are some of the injuries that can result if you choose poorly in terms of an adhesive. You can get folliculitis, irritation of the hair. You can get contact dermatitis. Something in the adhesive is causing a reaction. Maceration. I mentioned the moisture management earlier. You can't keep the moisture in, so having moisture vapor transmission in your adhesive is particularly important, not to trap moisture, which can sort of the get out of the bath after an hour phenomena when you have so much water trapped in your skin. Skin stripping, that's stripping off that top layer of skin, which can cause infection and other problems. Allergies, that's why we do a lot of biocompatibility. Tears, again, something you want to avoid. Your mom asking you, do you want the bandage taken off, grip it and rip it, or, extend the pain. Extend the pain, low and slow. Never do the grip it and rip it, or you'll have those types of issues. And then application process is particularly important in avoiding blisters. If you stretch the adhesive when you apply it, that material can relax and cause blisters in the skin. Risk factors for medically adhesive-related skin injuries. So we talk about, you'll hear this when I talk about our clinical trials. We're working on 3M volunteers that are healthy and active people, and so those are the people that we have access to really understand the performance of your device. You need to work with a population of people that are going to be wearing them and have the condition. But in order for us to understand our property, we work with relatively healthy people that volunteer for these studies. Anyone that's immunosuppressed, skin changes, avoid the sun if at all possible. The more I read about this, sun is bad. Extremes of age can cause that we've talked about, and then the choice of adhesive. We have a tool out there, one quick advertisement just for findmyadhesive.com. If you're thinking about working with a medical device, you can go online, walk through your process, how many days, what's the application, what is the size of the device, and it'll take you through and offer you some choices for what type of adhesive to use, at least to start doing trials on. I'll just quickly walk you through some of the trials we've done with our adhesives, again, to try and get what customers are asking for in terms of extended wear. So given that 3M's been in this market for 60 years, in medical tapes, when we started doing our clinical trials, we just took the products that we have today, applied those to people's skin, and then tried to understand how long they last, but also making sure that we do no harm, no injuries, no pain upon removal, those sorts of things. And so in the bottom left, you'll see sort of a peel machine that we have. It's an odd device that can actually measure the force required to peel off some of these tapes. We asked people to wear these for 8 days. Tried a variety of different materials, used a lot of replicates so that we would get statistical information. And then what we found was, based on, again, 60 years of experience, for applications in a hospital that typically are meant to only last 2 or 3 days, we had a few things that worked well and a few things that didn't work very well because those were never really designed to last for extended periods of time. So we've taken all of that knowledge and gone back and gone through another series of studies, and now we're starting to do studies out to 21 and 30 days. And so, again, very similar to what we did with the 8-day trial, put these on people's chest or abdomen or back, have them go through their normal lives, normal activities. We asked them to avoid hot tubs, and that was the main thing we asked them to avoid. A lot of runners, a lot of active people in the summer, so a really good representation of what these materials would face. You'll see kind of a cliff when we get out to that 14, 15-day range. So these are just materials as they fall off, as going from 0 to 21 days. We really do see it at 14 days, a number of these tapes fall off. And again, that's associated with this renewal of the skin and the natural sloughing off of that top layer of the stratum corneum. So this is going to be a real challenge as people try and go out to 21 and 30 days for continuous glucose monitors and other things. We all know continuous glucose monitors offer tremendous benefit for people opposed to the 4, sort of the spiky control of glucose in the blood. And so we really do want to provide a solution for this because it will impact people's lives if they can wear them longer and follow through on their use of those devices. The other aspect was just making sure we had no skin reactions, no irritation, very low responses to that. Typically after removal within 30 minutes, you would never know the tape had been applied. Very low pain associated with the removal of these materials after 21 days. And in fact, at 21 days, they were almost easy to take off because, again, that top layer of skin was becoming less and less adherent. So enough about tapes. That's not really that interesting. What about devices? And so we've done things now with simulated devices where we put those on the skin as well, measure the response. And so this, again, some pictures of these studies with a kind of a polycarbonate material, simulating a device, and then we let people go through their lives and wear these. The big finding from this is that you really do want what we call a skirt around any medical device. And a skirt, if you can see it in some of the pictures, there's an extended sort of realm of the adhesive that goes beyond the device itself. And what that does is it's kind of a shock absorber. So as you take off clothing, things happen, you bump into things if you're wearing that device. That really does offer a way for the stresses to get de-energized into the adhesive as opposed to creating lift on the edge of that device. And so, again, just something to keep in mind as you're looking at these, make sure you include that design of a skirt. Last one, just as we've gotten smarter and better at this, we now have what we would call essentially what we offer to most people looking at 14-day wearable materials. And so it's our 4076 product, which launched earlier this year, that offers almost complete adhesion for 14 days. The one person that fell off was a daily runner. And so again, there's going to be sort of a distribution, a bell curve of people in terms of sweat, oil, other aspects of their lives. There's going to be good adherence, and there's probably always going to be some outliers where it's very challenging to adhere to. So again, skin being very unique and very personal, there's no universal solution yet. In summary, hopefully you understand a little bit more about skin, why it's a challenging material to work with and stick to. We're trying to avoid injury. So first and foremost, we want to provide the value of the medical device. At the same time, we don't want to create any unintended consequences. Our lab tests can only tell us so much, so that's why we do so many clinical trials to really determine how things are going to perform on skin. We hope with additional modeling and understanding associated with this, we'll be able to be more predictive so we don't have to do everything with a clinical trial. And we hope to work with customers where we can test these devices on people with the condition that they have. Just healthy Minnesota volunteers can tell us only so much. Working with the people who have these challenges and are living with these challenges is the best way to learn how these devices are going to work. So we have extended wear now, working on 21 things that last truly 21, things that last truly 30 days, and then we're hoping to continue to develop these and have impact on people's lives going forward. With that, I'll end.